Well, good morning, good afternoon, and good evening, everyone. Welcome to our global webinar on optimizing aqua feed production, focusing on maintaining quality and the role of moisture. I will give it just a few more seconds because I see that there are a lot of people who are still dropping in. So I'm just going to hold for just a little bit to make sure that everyone is ready and settled. I still see a few people. Okay, let's get started. Well, welcome to this webinar. My name is Chantal van Lin. I am hosting this webinar for today. You don't see my name and photo on this picture because I am filling in for Marcella at the moment, who unfortunately had some personal things that she needs to address. So I am more than happy to welcome you here in this webinar and host this webinar. But before we get started, I want to mention a few administrative points for you to keep in mind. Before we get started, you are welcome to ask all the questions that you have for our two speakers for today. You have a GoToWebinar pane, and in that pane you have a question section. If you type in your question there, I will see them come in, and we try to answer as many as possible in this webinar. If your question is not answered, we will make sure that after the webinar we will come back to that and give you the answer properly. We have this Q&A after every session, so after every speaker, but by all means just start typing already when you have a question, so we can already see it come in. We have also two poll questions for you, so you can have some interaction. So be aware of that comes in. You will see that pop up in your screen, and you can click the answer, and I will see your answer coming in as well as a whole. Last thing, this webinar is recorded and will be shared afterwards. So, too fast. So I'm now going to the fun part of this, just introducing our speakers. We are starting with Jan Donkers, Mr. Jan Donkers. He is one of our guest speakers of today, so we are really happy that he is here. He graduated at Wageningen University in the Netherlands in 1996 with a master's degree in bioprocessing engineering. Since 2023, he was being part of the Agricultural Research Center of Skretting in Stavanger, Norway, as a researcher for feed processing and technology. Within Skretting, he headed the feed production R&D department, focusing on developing and executing the R&D portfolio for fish and shrimp feeds, and optimizing feed processing for all Skretting aqua feed plants with a combined annual production over 2.4 million tons of feed in 2021. So that's quite a lot. This year, Jan started his own business, providing consultancy services and expert advice in animal and aquatic feed processing and production technologies. So we are very happy that he could join us today to share his experience. So welcome, Jan.
Thank you.
So our second speaker is Saravanan. He asked me not to pronounce his last name because that is very difficult. So I'm just going to call him Dr. Saravanan. He is our Global Program Manager Aqua at Selco Feed Additives. Saravanan has a PhD in fish nutrition from Wageningen University in the Netherlands. He is originally from India, but he's currently based in Norway, where he's joining the Skretting for 6 years ago. During his time at Skretting, he held various roles in research, production development, product development, and product management. In 2021, he joined Selco as a global program manager for aqua in the feed additive department. So also you, Savran, thank you so much for helping us and share your experience. So with no further ado, I'm just going to give the floor to Jan. You have control over the slides if all went well, Jan. So I am just wishing you all a very good webinar, and you will see me pop in and out for the poll questions. And when you have questions, please, by all means, once again, share them via the question pane in your GoToWebinar tool.
Yes, thanks a lot, Chantal, for the nice introduction. Oh, now the slides disappeared.
Oh.
Chantal?
Yeah. Oh. Yeah, I see it. For some reason, you can't see the slides anymore. Let's see what. Oh, the funny thing is, I see them still here on screen. Sharing. Share screen. There you go.
Yes.
Perfect. Well,
thank you. Thank you.
You're welcome.
Okay, let's see if we can identify some opportunities to optimize aquafeed quality, and with this to improve the economics in these times of increasing energy costs and increasing raw material costs. So the topics I would like to discuss. Let's see if I can get control. Seems like I don't have control.
Do you have it now?
Try again. No.
You can't click them. I'll go and click for you, Jan.
Yes, let's do it like this. Yeah, that's easy.
For some reason it is not. There you go. Can you see your overview now? Because the funny thing is that what I see on my screen is something else than that what you are seeing.
Yeah, I still see the first slide.
Yeah, which is rather funny. Oh, it's no nice night when you start practicing, all goes well, and then all of a sudden.
Oh yeah, technology.
Yeah.
Yes.
Can you try and click now? Yep.
Yes.
Here you go.
Now it works. Yes.
Perfect.
Good. Thanks a lot. So
sorry for the delay.
No problem from my side. Okay, the 4 topics I would like to discuss in this session. First, the importance of feed quality, then feed quality parameters, feed processing and quality, and as last one, the role of moisture. So let's start with the importance of feed quality. So if we look at this first 2 pictures, you see feed in storage. If you zoom in to the yellow circles, you see feed that is at the bottom of a pile of feed bags, and these 4 pellets at the bottom, they have a lot of force on top of them, and these pellets should still stay intact. So they should be very strong and have a good durability. So they should not crack, they should not break, they should not leak oil. So that signifies that durability and quality is very important for this feed. Another example here is coastal farming. This is quite common for example, salmon farming across the world. In this type of farming, often pneumatic feeding is being used. So you see these white lines in the water, so that are the feeding tubes, and the distance of these feeding tubes can be quite long. I've seen them up to 1,000 meters, and there are even systems up to 1,400 meters. And the feed is really shot through these feeding pipes with compressed air. So a lot of forces are being applied to the feed, and we still want to get whole feed out of these feeding pipes at the end. So you can imagine also here we need a very strong pellet and a high durability. If you have any dust formation in these pipes, or if you have dust in combination with some oil leakage, then you can easily block these pipes, and then you have an issue at the farm. So that also stresses the importance of feed quality and durability. So if we then go to the next slide, this shows a new trend in the industry, offshore farming. So far out in the sea, you can find these units. We have them. There are a few test installations in operation now in Europe and also in Asia. And these are huge installations. The volume of this one is 250,000 cubic meter. It can take 1.5 million salmon. And so you can imagine that to run these installations, you need a huge amount of feed. So this will take a lot of logistics, big volumes of bulk transport. So a lot of handling of the pellets, and also that can give quite some stress to the pellets. So also here, durability is very important, and quality is very important. Then the next trend in the industry is land-based farming. Having the tanks on land. So here, the majority of the water is being reused. So it is flowing through filtration systems, amongst others also biological filters in these units. So here it is very important that the feed is not influencing the filter system, that there are no residues of the feed coming to these filters and disturbing the filters, and by this disturbing the water quality, because that could lead to a big issue of these farms. So also here, things like water stability, no or really minimum fat leakage is of utmost importance. Also here, quality is key. Then if we go to the next one, we have pond farming. This is used a lot in fish feed and in shrimp feed operations. So here it's also important that there is, for example, almost no dust, because everything that is not eaten by animals is ending up in the water, in the pond, and it will also influence the water quality. So also here, durability and low amounts of dust is very important. Shrimp farming. Shrimp is a slow eater, so they really like to nibble on the feed, and it can take up to a few hours before the feed is completely consumed. So also here, water stability is very important, otherwise you will also lose nutrients that are not available for the animals anymore, and you will also foul the water. So also here, quality is an important parameter. So this all shows that feed quality is very important. There are many opportunities here. With improved quality, we could have an improved animal performance. If we can reduce the dust or we improve the water stability, then more nutrients are available for the animal. So that is very helpful. With improved quality, we can also have a better farming equipment performance. So the clients, the customers have a better utilization of the feed. Feed mill performance can be improved if you have lower amounts of dust generation. You have less waste in your plant. This will be also a benefit for your plant. Quality adapted to purpose. In the previous slide, you see that a lot of different uses of the feed. So one time we could focus on water stability, another time maybe durability is the most important. So we could also adapt the quality to the purpose and not only making one standard quality. And then if you are able to lift the quality or have a very good quality of your products, you will also be able to improve your brand value. So a lot of opportunities here. Then next section is about feed quality parameters. There are a lot of different feed quality parameters. A long list here. The list can even be longer. If you look at a few of these parameters, no oil leakage, durability we already discussed, sufficient shelf life, no microbial growth, so things like this. And also then if you have control over these parameters, if you have a good control over the quality, then you could also become more flexible with the composition, the formulation of the feed. That's on top of this page. So composition adapted to the current raw material market. So then you would be flexible to change to different recipes. And that's very important at the moment with all these supply chains disruptions. So that is also part of a good control of quality of the feed. If we then dig in a bit more into the details, durability, as already mentioned a few times, is very important. There are different tools available on the market to measure the durability. So here it's good to think through what is really important for you and for your customers. Should there be focus on the resistance against friction, for example, during transport in your plant or at your customer's location? Or are you looking for the effect or the resistance against impact to the feed in, for example, these pneumatic feeding systems or other systems that can have an impact on the feed? Are you looking for static pressure, like during the storage of feed? So based on these considerations, you can then pick the best method to measure durability and to get control of this. Then there's another example. Color is very important. This is the first thing that customers will see of your products. So if there is a variation between different batches of feed of the same product, then a customer could react to this and say, oh, there is something wrong with the feed because the color is completely different compared to the earlier delivery. So yeah, that's something to also look at to get control of. So often this is linked to uneven process. If you have instabilities in feed color, it can be moisture variation, variation in raw materials. The formulation itself is of course important. So the main near suppliers, they can deliver a module that you can measure feed color. So as soon as you start measuring it, you can also try to optimize it and to improve this parameter. And then we already mentioned water stability, also a very important parameter. So there are very nice handheld, quick methods at the market at the moment, where you can measure the water stability of your products. So you measure in principle the turbidity of the water, so how many particles are present in the water. So the more particles in the water, the higher the turbidity. So it could also be a quick check to see how the feed is performing and how it will perform at the site of the customer. And then it's time for the first poll.
Perfect. I'm coughing. I'm going to launch the first poll. Here we go. And if all is okay, you all see the poll question in your screen.
Yes, I can see it.
Perfect. And I see that people are voting. That's also perfect. I'll give it a few more seconds. Almost 50% of you voted. That's great. All right. I'm going to close the poll and we will see the results. So I think the audience did pretty well.
Okay, 84% all of the above. Yeah, that's the correct answer. Yes. It's a quite wide area, quality. It influences a lot of different things, and all of the above are correct. Yes.
Perfect. I'm going to hide it again and close it, and you can.
Yes, then to summarize the opportunities within feed quality parameters, there are opportunities within fast methods. There are more and more fast methods available, and can also be developed new fast methods. So if these are available, then you have also the possibility to use these methods on site. So you don't need to go to an external laboratory anymore. You can just do it in-house on site. That's very convenient. And there are even developments within handheld or inline equipment, so that you can really go to the line to do measurements, or to go to a customer to do measurements. Or with inline equipment, you can even have instruments in the line that give you automatically some data that you can use in the quality control system. So a lot of opportunities here. And then as last one, adaptable quality, as we have seen in the previous slides, a lot of different applications of the feed, a lot of different uses. So then we can also adapt the quality. So we can steer towards improved water stability, for example, and then next time we can steer against the durability, depending on the needs of your customers, for example. So then if we move to the third topic, feed processing and quality. Oh, that's too fast. Feed processing, a lot of different variables in the feed processing plant. A lot of these can be controlled, like the plant design, the processing conditions you can choose yourself, what kind of raw materials you're using is also in your own control. But also uncontrolled parameters like raw material variation. So one time a product can be different from the next time, depending on the season. Environmental conditions can fluctuate. In the summer it can be hot and humid, and maybe a different time of the year it can be a lower humidity and a different temperature. That can all affect the processing. So then how to cope with this? So first have a look at the things we can control. So one of these things is, for example, grinding. I often say quality starts with grinding. Aqua feed often needs a finer particle size compared to, for example, compound feed. The animals, the aquatic animals, have a very short digestive tract. So then it's helpful for them to have a fine particle size. It is easier for the animals to digest the feed. It also gives a big benefit for the process. So if you look at the right side of this slide, you see if we grind the product finer with the same volume, we have much more surface area. So it means it's easier to process these particles. It's easier to cook them, to gelatinize the starch. It makes things much easier. So grinding is a thing we can control, and it has a direct impact on the feed quality. Then before your pelletizer or your conditioner or your extruder, you often have a conditioning step. There are two things to take into account when you think about conditioning. Here on the top of the slide, the first thing is that moisture transfer is slow. And the second thing is the bottom of the slide is that energy transfer is much faster. So if you look at the graph, the top graph, for example, at the particle diameter of 500 microns, it takes almost 20 seconds to hydrate this particle. But if you then look at the heating time, it's only a few seconds to heat this particle of 500 microns. That's good to keep in mind. And there's also influences how we should run the conditioner in the plant, because water needs some time to get into the particles. It is recommended to first add water to the conditioner, give it some time to penetrate into the particles, and then later in the process, as a second step, add the steam, because that is very fast to heat the particles. And if you're using any lipids, then it's better to use these in the end of the conditioner, because otherwise it will coat the particles, and then you will limit the cooking and the moisture penetration of the particles. Then in addition, it's quite good to add the water at the top of the conditioner and steam at the bottom. Water wants to go down, steam wants to go up. So then you get a good interaction of all the injections with the particles. Then, for those of you who have extrusion implemented in the plants, if you have extrusion, then you have an expanded product. So you have some kind of porosity in the product. And porosity has also a direct link with the quality. So a lot of factors can be variated in the extrusion process. And by this, you can also influence the porosity and the structure of the pellet. So in the end, it's very important for the expansion, the temperature of the mix just before the dye, the pressure, the viscosity, the moisture content, the raw material mix itself is very important. Smaller amounts in the raw material mix can already have an impact on what the pore structure is. So you have a lot of things to play around and to influence these pores and the structure of the pellet. That also has a direct link with how the pellet will behave further on and what the quality of the pellet is. And then it's time for another poll.
Well, if all is well, you can see it on the screen now. What is the correct way to operate the conditioner? So let's see who of you knows this. There the votes are coming in. Very good. And even if you don't know, you can just take a gamble. It is if you already know everything, then this webinar is not the best place. But just take a gamble then. But I look at the results. I think you're doing a pretty good job. Well, I'm going to close it. I see that there are a lot of people voted already. Here you go. And here are the results.
Yes, 74% for adding water first and steam later. And that is indeed the correct answer. So that's what we just discussed. Water needs time to penetrate the particles, and steam acts very fast, so that can be added later. That was the correct answer. Yes, and then to summarize the feed processing part, what are the opportunities? Control what can be controlled. Inline measurements and control is very important. And also upcoming, I see more and more applications of inline measurements and feedback loops, so that there is automatically a change in the process conditions based on measurements done during the production. So that this is also something that will develop further in the future, I think. We discussed a bit about what can be controlled and how to control this. There's also natural variation that is a bit more difficult to control. Like if you get a new batch of fish meal with a completely different functionality or a different quality, how to handle this. So first thing is then to be aware of what can be different. So it's good to have an overview of what could fluctuate in your process, in your plant, and then have a kind of plan of can you measure it and can you handle this. So for example, with the fish meal quality, you could maybe look into dividing it over different bins and put fish meal with a high quality in a different bin than fish meal with a lower quality, and then use this lower quality for more easier products that have no big issues with durability, like for example smaller products, and use the really good fish meal for the more challenging products. So it's good to have systems like this in place that you can handle natural variation and are not surprised if something hits you as a surprise. Then it's always good to adapt the process to the purpose of the feed. So think about what is the challenge for your customers and how can I change the quality of the feed and change the process so that I'm really making the quality that this customer needs. And then, of course, also increased feed mill performance. If the feed processing is improved, then you will also reduce the amount of waste in the plant and increase feed mill performance. Then we get to the last section of this presentation, the role of moisture. So here on this picture, you see a particle with a very big dry core. There is a small moistened part surrounding the particle. And then if we add steam, then this will mainly cook the moistened part. So the starch in this part will be cooked, and it's much more difficult to cook the dry core because it's not moistened. So how can we improve this situation? The different opportunities to influence this. For example, particle size, what we discussed, a smaller particle size is easier to cook. Water temperature can help. Hot water is easier to penetrate into these particles. So the application of hot water can be important. Mixing efficiency can help. The water droplet size can help. The smaller droplets will be easier to distribute over all the different particles. The use of surfactant can also help to distribute the moisture over the particles, and then also the proper conditioning, as we discussed earlier, first water, then steam, that can all help. And then if you have some of all of these parameters in place, then you can end up with a particle that is has a higher amount of moistened material and a smaller amount of this dry core, or even no dry core anymore. And then it's much easier for the steam to cook the complete particle and to have a better hygiene in the process. And it's much easier to process the whole mix of particles. So then also the moisture content of the final feed has a direct link with the feed quality. So the feed moisture content is important for the durability. So most of you will recognize that if you have a feed with a very low moisture content, it gets very brittle, it's easier to break. So then you get a low durability. And the other way around, if you have a much higher moisture content, it's more flexible, the pellet. So then it has a higher durability. So this is a nice correlation that if you increase the moisture content of the feed, then you should expect that the amount of broken pellets and dust goes down. So it's good to see if you also recognize this in your own products and to try to set some borders. So if you know what is the durability versus the moisture content, you can maybe define some areas that you need to have a minimum moisture content to have the best possible durability. So here you can do quite some optimization. And then, for example, in this picture, the red area would be the lower moisture contents, and you would like to avoid this in your production process. The yellow part, it's okay, but could still be improved. And you really want to be in the green area with the higher moisture levels to have the best quality in your feed. And then energy is a hot topic at the moment. Energy prices are quite high. So if you look at an extrusion plant, 50% of the energy consumption in an aquafeed extrusion plant is due to drying. So if you can reduce this a bit, that will have a significant impact. So for example, you could look at raw material selection. Different raw materials absorb a different amount of moisture. So you could look at raw materials that have a lower amount of moisture need. So that will reduce the amount of moisture in the process. You could also think about using a product that contains a surfactant that will smooth the whole process, and that could also reduce the amount of process moisture. You could look at process optimization, like we just discussed for the conditioner. And all these things could reduce the process moisture content. And then if you look at the table, then only a small amount in moisture reduction will have a big impact on reduction in water removal of the dryer, so of the dryer load. So 2% will already give a 16% reduction in dryer load, 3% and even a 24% reduction in dryer load. And this is something you will for sure recognize on your energy bill. So that could be interesting to look at this and to see if there's something to optimize here. Then to finish the moisture part, the opportunities here are improved hygiene and processability. If you use moisture in the correct way, the optimal way, moisture is an important tool to improve feed durability. And then improved utilization offers also potential for energy savings. So that's also quite relevant, certainly today. So with this, I hope that I gave you some inspiration for areas where you could look at quality and improve the quality of your feeds.
Perfect. Thank you so much, John, for your story. We have questions coming in, so I'm just going to throw a few at you. Looking at time, we are going to do 2, and then the rest we will make sure that we answer after that. Is there a difference in the quality of feed that is made by a single versus double screw extruder?
Oh, that's a very good question. And that is still a lot of debate amongst people in the industry. But in my experience, it is possible to make good quality products with both systems. So there should not be a difference in quality if you produce a single or a double screw extrusion. The benefit of double screw extrusion is often that you can handle a bit more difficult materials. It has a wider window of operation. So, for example, you can use higher fat levels in the extruder. But it's perfectly possible to make a good quality feed with both systems.
Perfect. Thank you so much. Then the second question. For sinking feed, shrimp, what are the key parameters of the process to improve the final product water stability? And how to mitigate the kibble expansion without sacrificing water stability?
Oh yeah, that is a lot of different parameters can play a role here. It is the formulation, of course, the starch content, the amount of binders. Yeah, so formulation. Then processing is important. If it is extrusion, then the porosity will play a role. If it's pelleting, it's also how the pelleting process is done, what is the conditioning, how efficient is the whole process. So it's a wide range of things that influence the water stability of these products.
Well, then with this question, I'm going to give you a big thanks for this presentation. And I'm going to give the floor to Saravanan. If all is okay, you have control over the slides, so you can click through.
Just taking some time. Good day, everyone. Thanks for joining in for this webinar. Yeah, it's happening. Okay, I'm going to talk a little bit for the next 20 minutes on the topic of moisture management, what Jan already touched upon, and how to what are the limitations and challenges with the pelleting and extrusion, and how we can enhance the efficiency and extend the feed quality. So yeah, the kind of overview of the presentation is I'm just going to briefly touch upon the general aquafeed challenges and production opportunities, challenges and opportunities, then move on to moisture impact on specifically on the role of moisture a little bit, then specifically on the limitations and challenges in pelleting and extrusion. Then I'm going to talk about the solutions, because moisture brings a benefit, but also at the same time some negative aspects. And then I'm going to talk about the third part, the product that can handle both the the negative side and the positive side of the moisture management in fish feed, aquafeed production. And then I should finally show up some trial results and summary. Moving on to the first part, aquafeeds are itself is a challenging compared to other animal feeds. When you compare with the it's taking time to move. When you compare with other animal feeds, land animal feeds, in aqua feeds, you are playing with pelleting. You're playing with pelleting and extrusion, but also different sizes, diverse feed ingredients used, more than 15 different ingredients are used. Wide range of fat is included. Have problem with water stability. Very important focus on water stability, and of course, sinking aspect is very important, and you need longer shelf life as well. And that's a challenge in the production manager or production operator or quality people in the factory or plant feed mill. Is important to balance the trade-off, to focus on the feed quality at the same time feed quantity. So that's where it's very important to fine-tune the balance between the quality and quantity of feed produced or throughput. Yeah, these are general challenges, but currently, there are challenges with logistics in terms of delivery, getting right raw material, right quality of raw material, but also delivering the quantity of feed, and also increasing energy price. It's extremely, we touched upon there, and also the overall sustainability. We want to reduce our footprint in our feed production, and of course the price. So these are the challenges, but of course brings the opportunity to, if you're able to maximize the feed production, extend shelf life, or reduce the lower energy, and overall it will reduce the cost of production. These are the opportunities, and how we can, with this presentation, I'm going to touch upon how we can snatch these opportunities, current opportunities. Yeah. Moving on to next one. Of course, it depends on, as I said earlier, if you have pelleting or extrusion, it's completely different. With pelleting, you have a challenge with limited moisture inclusion level. And of course, you cannot dry the at the end of the process, you cannot dry, and that means you have to play with what you have. Yeah, and of course, one of the big risks is linked to the mold. If you have excess moisture in the final feed, you have a risk of mold contamination. On the other hand, in extrusion, you have plenty of water that you are bringing in because you to make the expansion, and of course, you need less energy, more energy, and then there you need to dry afterwards, and that's very expensive in terms of energy. So so a little bit on moisture impact, role of moisture in aquafeed processes. If you look, moisture is very important for starch generation and protein hydration. It's very important for cooking, very optimal cooking or better cooking, which improve the digestibility. That's very important for the growth or FCR. And it also helps to lubricate and reduce the friction and enhance the throughput. So having a right moisture is very important. And also it plays, as Jan mentioned, it plays an important role in pellet quality, stability, durability, color, a lot of aspects, and energy, but also the hygiene part, which I touched upon. If you leave excess energy, excess moisture in the final feed, you have a risk of spoilage through microbes and mold that you don't want to have. Yeah, this is the general process of moisture and temperature profile of pelleting process and aqua feed, and also in extrusion process. You start with the raw material roughly with less than 12% or 12% moisture level, and in the grinding, in the pelleting process, you start grinding, you lose some moisture. That's actually you don't want to lose because you are using pulverizer. But again, there is an opportunity to add some more in the mixtures through special surfactants to increase the penetration of moisture, and then at the end you are able to get better moisture level. And of course, all the production people and quality people is looking to attain a certain level of targets that they're assigned depending on the product, and everyone is trying to stay below. But actually, you have possibility to increase the throughput, get the benefit out of it, and also avoiding the risk of mold. On the extrusion, again, you see here you're having a very high moisture. Of course, you're using much more than what may be needed, because if you optimize, you may need less. And then, you can, if you are using less here, you can dry less and to get the right moisture in the end, yeah. So reducing the energy needs for drying. Yeah, so this is an example. I just focus on the moisture loss in pelleting. This is a challenge, and this is an in pelleting process. When you start, if you don't do anything, you are starting at 12 and you grind, you lose the moisture level. Then if you don't do anything in the mixing part, this is in the steam, you bring the steam in the conditioner and you get a moisture level of 14. Then after the pelleting with the thermal energy, you get down and doing the ambient without drying and doing cooling. So you are less than, you will be less than around 12% or 10 to 12% or even lower, depending on your operations. But there is an opportunity, to add, to gain the moisture, to add the mixing part with Filex 4, for example, this is one of the, and also anti-mold property. So you can increase without any risk the moisture in the mixing, and then thereby you are able to have a better conditioning, better starch gelatinization, better binding, better pellet quality. And at the end also you can keep higher moisture level. You can increase moisture level by 1. You have a better feed quality at the end. I will start as to, now we are moving to a poll, which is linked to the next topic. Chantal, can you just start a poll now?
Yes, I can. Here you go. Yeah. So the question is, how much energy is required to evaporate 1 kilogram of water?
This is linked to the this question is linked to the aspect how much energy you need or you can save in the extrusion drying process. So it's let's see what comes out, what people think.
The votes are coming in.
There, yeah, you can choose. Even this is just to learn. So
yeah, no problem when you don't have the right answer or you don't know exactly. Just giving it a few more seconds. There's still votes coming in. Okay, I'm going to close and I'm going to share, and you can see.
Hey, of course. Oh, it's very good. Actually, yes. I'm happy to see the good answer. Actually, the right answer is 2,400 kilojoule is needed to evaporate 1 kilogram of clean water. So that's right answer. Actually, yeah. So.
I want to hide it again. You have around 12 minutes still, Slavanon, just to check on time. Perfect.
I'm just trying to move the slide. Yeah, good. As you answered, about 2,400 kilojoule of thermal energy is needed to evaporate 1 ml of water. 1 kilogram of water in in general, theoretically. And of course, in extrusion process, we bring thermal energy in forms of hot water, and also through steam in the extrusion, and we reach about 20 to 30% moisture in the extruded. And afterwards, actually, we dry up, we evaporate all the water. Just in the main purpose is to to preserve the feed from the spoilage, around 7 to 10% moisture. And that means to produce 1 ton of feed, we need to evaporate roughly 300 to 600 liters of water. And as the total thermal energy needed to evaporate, or per ton of feed to extrude is about 186 kilowatt per ton of feed energy is needed to produce 1 ton of feed, extruded feed. And roughly 50 to 60% goes to drying process. So if you are able to reduce reduce the moisture in the process, you are able to save a lot of energy in the drying process. Each percent reduction, you gain 8% savings in the to evaporate. So again, that's not other aspect is, if you're able to the amount of energy needed to dry the moisture it's not linear. So actually, if you're able to drying 10% moisture, you need less specific energy per kilogram of water. And if you're drying to 8 or much lower, you need to put more energy to get this, to get the water out of the pellet. So it is important to optimize the moisture management in extrusion process. Next, I'm gonna talk. These are the challenges, but of course, considering all the challenges, we have a product solution that calls Phylax 4HC, which is able to manage both the mold control, but also the better moisture management in the extrusion process that leads to better feed production efficiency. So what I'm going to discuss in this part, what's Phylax 4, how it is, what are the benefits. Whole time, Chantal, before going into detail.
Yes, I'm going to pull the last one up. Here we go. What type form of mold inhibitors are you using in aquafeed?
In your aquafeed.
Yeah, I see people are voting. Very good. Very active group that we have today. Yeah, there are still votes coming in.
Yeah.
Just going to give it a few more seconds. There you go. Perfect. Going to close.
Yeah.
And here you can see the results.
Okay. So, I think if I look at the results, more than 60% of people are using, majority of them are using dry form or calcium propionate or dry form of mold inhibitors. Yeah. And I think after this, it's good. Yeah, good to know this information. And after this presentation, you will realize maybe to reconsider some other things. Yeah. Yeah, we can move on to yes, this is considering the specification. Typically, we know, calcium propionate is historically used as an press the button before used as an anti-mold inhibitors or other forms of dry form is used because it's easy convenience. Yeah, of course, it has a limitation. It has a possibly easy handling, and that's the only part I think you just put into the mixer. But then you lose a lot of the advantages of moisture management with the dry products. Yeah, so not completely. So with taking into consideration, the Phylax 4 is developed with an active prop technology that is actually, it takes into both the mold inhibition part, but also the moisture management part. So it contains 4 aspects. The active prop technology includes 4 different aspects. One is the propionic acid, free propionic acid, one of the most effective and broad spectrum organic acid against molds. So that includes, and that's taken to take care of the mold, and then emulsifier is an integral part to help to form the, to reduce the surface tension of water and also also in the water, but also on the, on the cell surface of the molds, so that the organic, it can break and the organic acid will penetrate and kill the mold spores. And of course, we also see synergies of using certain phytochemicals in addition to propionic acid to as a very good mold inhibitor. I will show some results later on. Of course, it needs to buffer, otherwise organic acids are very corrosive. So we use a specific buffering agent to minimize the corrosion, but also to reduce the evaporation rate of the organic propionic acids. And this is a patented product from us. So first aspect I'm going to touch upon on the surface tension. Phylax for the surfactants in the Phylax 4 reduces surface water surface tension. What is water surface tension is actually, if you look if you look here on the bubble, this is let's say pure water. It is just not spreading, so it needs more energy to spread. So that's how. And water has a very high surface tension, just pure water. That's why if you see the on the pond or lakes, you see a small even insect can walk on top of the water. So it's very strong force. And that is actually you don't want in the extrusion or pelleting process, because that means it is difficult just for pure water. It is difficult to penetrate the inside the core of the particles for better cooking. So by using the Phylax Fort, we have tested many products, many combination, and then what we see is using Phylax Fort liquid, we are able to significantly reduce the surface tension of water, and this is very important in both pelleting and extrusion to make better moisture penetration into the particles. That leads to better cooking, better gelatinization, and better pellet stability or pellet quality, physical quality, and nutritional quality as well. Next part of is, we have tested this, we just don't come up with something. It is long researches behind that. And, we compared the effectiveness of pure buffered propionic acid and buffered emulsifier with phytochemicals in addition to that, and also the additive effect. So clearly when we are using the ActiProp against two different molds, Aspergillus and Penicillium, we see clearly because the ActiProp technology is far better, and you see the synergetic effect of combining the buffered propionic acid and emulsifier leads to far off better mold inhibition, or cell penetration. Next part, just to highlight, and again we tested again with the calcium propionate. Use many of people showed you're using calcium propionate or other form of dry products similar to that. I know you need roughly people, we tested in a trial, it's stress test. That means how long it takes if you apply those different products at same different concentration, how long it takes to appear mold. And when we are what we see is when you're using 1 kilogram of, this is in the blue bar, what you see the number of days it takes to, or relate to day in a percentage to take the appearance of mold. And then this is the amount of products we included in those tests. So when you see the results, what it says is, the Phylax Fort XA application is providing 1.7 times more shelf life by using Phylax Fort compared to, for example, calcium propionate or ammonium propionate or other dry products. And also we have a 40%, you need actually 40% less than what you're typically used to do. So it gives a value for it. Again, we compared this with many products benchmarked with other liquid mold inhibitors, to know how good is our product or how it is. We tested many products in the same inclusion levels. What we see clearly is compared to control group, which we don't have any anti-mold inhibitors. Phylax Fort HC gives 1.8 times more shelf life. You see, compared to other liquid products, it is giving a much better extended shelf life for feed and protection from mold. Next one. The trial summaries, of course, these are lab trials, and we have done a lot of field trials, commercial field trials. I'm gonna go into a couple of them, aqua specific. We have done trials in more than 100 different trials, both in laboratory controlled conditions, but also in commercial conditions, and in 5 different continents, and also tested in many different species, including fish feed and also shrimp feed. So I'm gonna take a couple of examples considering time constraint. This is the trial one. We tested in pelleted aqua feed. It was done in China in one of the big facility where we tested, 2 groups where we didn't add any preservation in the control feed, and on the treatment we added 15 kilo water and then 0.6 kilogram of Phylax Fort HC. And then what we observed is, the production parameters. What we clearly see is, the moisture content in the final product improved by 1%, 1%, and also the production efficiency is increased by 13%. That means the throughput has increased by 13%. The other one, we also did a trial in extruded aqua feed, and then there we had 2 treatments as well with no preservatives, and we are aiming for 9% moisture, and the other treatment we are aiming for 12% moisture. And there we added, of course, you don't need to add extra water because you already have a lot of water. So we just added 1 kilogram of Phylax Fort to see what's happening. So what the outcome of the main outcome, what we can say is we are able to increase the moisture content in the treatment group by 2%. That's a lot in my view. And then the energy consumption was in the drying was reduced by 27.7 kilowatt hour per ton of feed. So that's very significant number. If I look if you produce multiply by 100 tons capacity feed mill. So with that, my final slide, conclusion slide or summary slide. Yeah. So what you get is, in the summary of file application or benefits of applying using file export HC is, in pelleting, you are able to optimize the moisture in the final feed by at least 1%. You're able to increase the capacity by 10% production capacity. You have a better pellet durability, which is from all the pelleting trials we have done. And it also have an extended shelf life because it actively inhibits the mold. And in the extruded aqua feed, you are able to optimize the moisture use in a better way, and thereby you can lower the process moisture needs. And also that means you can also reduce energy in the drying. And these also have a possibility to expand the production capacity, because sometimes in extrusion the drying is a limitation for throughput. And of course you have also extended shelf life as well. So based on all of the trials we have done across different species, what we see clearly is we are able to get, with the use of Filax Forte, you are able to get a return on investment of 3 to 1. Of course, it differs depending on the feed mill and your current status and local conditions. With that, thank you for listening to me. And any questions, I'm happy to answer.
Thank you so much, Saravanan, for your presentation. Looking at time, we are already a little bit exceeding the time, so I'm just going to pick one question, and then the rest we will do after. I think we touched upon this topic, but maybe it's good to address it once again. Can the moisture content in aquafeed influence the presence of mycotoxins?
Of course, yes. So if you have high moisture level, it is prone to mold infestation or growth. So with high moisture, the mold will grow, and then the molds, of course, they produce, when they're stressed, they produce the mycotoxins. There is a risk, if you have high moisture, there is a risk of mycotoxin. But then if you're using a proper anti-mold agent, then you are not having any up in that risk. So you're taking care of that.
Perfect. And looking at time, I think I'm going to thank you, Jan, and thank you, Saravanan, for your presentations, for a nice story. I see some thank yous coming in the chat as well, so that's really good to see. Thank you all for listening and tuning in. Hoping to see you around for next webinars that we are organizing. So thank you for being here. Have a good evening, a good day, wherever you are on the globe. Hope to see you soon, and stay safe.
Yeah. Thank you,
Bye.
everyone. Bye. Take care.